G'day guys, today we're going to talk about VLANs and how to program them, and we'll implement them into our network that we got going on. I posted up the PowerPoint presentation here. Read through it. I'm just going to skim through a lot of the stuff and just hit some of the more important points. VLANs, they're generally going to be used to just separate data within your network. Users, clients, networks, all that, at a cheaper cost. VLANs are virtual groups of computers, like of LANs. You can take, rather than having, like, if you have three networks, rather than having three separate switches, one for each network, you can just have one switch that's broken up, depending on obviously on the size of the network that you have. So here's an example, having two different networks with one switch. One thing I didn't really get into with switches is that they create broadcast storms. What happens is when, let's say all these computers, they're all on the same network, and they all just get plugged in, and the switch doesn't know who anybody is. When computer A wants to talk to computer B, when he sends out his first packet to the switch goes, I don't know who B is yet. So when a switch receives a packet from when it receives a packet to a destination it doesn't know, it forwards that packet out every single port except for the one that it came in on. So in this example here, computer A tries to ping computer B. The switch receives it and pushes out that ping to computer B, C, and D. C and D will obviously ignore the ping because it's not meant for them, but B will then reply back. And the problem is, if you have multiple devices in there, like multiple switches, if switch A receives a packet from somebody and doesn't know where it goes, it broadcasts out every port that it has to another switch who receives it and doesn't know. It'll broadcast out every port that it has, and then it will create this giant broadcast storm. I don't have a very good diagram up right now to demonstrate it there, but when it does, whenever a switch doesn't know where to send something, it will constantly just broadcast it out every time it receives it, out every port except for the one that it received it on. But here it breaks everything up, breaks up broadcast storms. VLANs are not created physically through layer 1. Here's an example. You can have 3 VLANs, one for sales, HR, and engineering, and you can have those clients all throughout your building on different floors and still talking to each other within their own network, and not having their data, sensitive data, pushed out on other networks. Okay, so the way VLAN works is, and I did up a little diagram to simplify what it looks like, is they tag packets as they come in and out of a port. And I made a little diagram here to make it very simple so you can visually see it. So I have computer, let me just try to make this a bit bigger. I have computer A right here, computer B, and computer C. And let's say this is the packet right here. When this packet, let me just make this a bit smaller. If computer A stop that. If computer A is trying to communicate with computer B, it sends this packet out. And as this packet goes into the port, okay, it gets encapsulated with another layer. And that encapsulation, it will just state like the port, what VLAN it was from. VLAN 1. Now this packet can only go out ports that are assigned to VLAN 1. In this example, these 5 ports right here are labeled with VLAN 1. Now it'll get tagged as it goes in, and then as it goes out, that tag gets removed. So if computer A is pinging computer B, this packet gets tagged, and as it goes out, that VLAN tag gets removed. So when the packet comes out of this port, it's just going to be the normal packet. Okay. Now, because it's tagged like this, while it's inside the switch, though, if the switch didn't know where computer B was, it would broadcast this packet out every port, except for the one that came in, but only the ones that are authorized for VLAN 1. So this packet would get broadcast out port 1, 3, 4, and 5. Okay, get pushed out. Obviously, this guy would see it, reply back, and then the switch would now know who computer B is, and in the future, like, it builds routing tables for each VLAN, not routing tables, but MAC tables for each VLAN. So in the future, it wouldn't broadcast it out every port; it would just send it to that one. If you notice up here, there's a native VLAN, okay, which native VLANs, everything travels through it, okay. Generally, you set up a trunk from switch to switch, and everything will go through it, okay. This packet, again, it comes in, gets broadcast all of them, but the native one is universal, so it will also go out that way. Now, when it gets to the router will just ignore it. The router doesn't acknowledge, doesn't forward broadcast. That's how they break up broadcast domains. They don't forward broadcasts. But the router will see this packet, okay? And it may or may not do something with it, but it won't broadcast it. So if I want to talk, if computer A wants to talk to computer B, without a router, it can't happen. There's no, the switch will not at any point strip this packet out and then re-tag it with VLAN 2. It won't happen, okay? Internally, you cannot talk to another VLAN without a router. Now, what the router does is, so let's say computer A is trying to talk to computer B. The packet goes in, it gets tagged with VLAN 1 information, okay? And let's just create another one of these. Hope you guys like my mad paint skills. Yay. Alright, so the computer is trying to talk to VLAN 2, this guy over here. So what's going to happen is he's going to send his packet. When it goes into the interface, it will now be encapsulated with VLAN 1. It'll go out, like if the switch doesn't know where to send it, it'll go out every port except for the one that it came in on, which would be port 1, 3, 4, 5, and the native one. When this goes up to the router itself, the router will be like, look at the IP address, because each network has its own IP scheme, okay? let's just say in this example, not what I want. This one here is the 192.168.0.0/24 network. Okay, and VLAN 2 is 10.2.5.0/24 network. Okay, and you're pinging this client, which would be like .4 or 5. This guy's .6, but part of this network, the 192.168.0.0 network, and he's trying to contact the 10.2.5.0 network. Remember, these are two separate LANs. They have their own network IP scheme. Period. You do not share IP schemes between LANs. Okay, it's not a thing. It won't work. Your network will just shut down. Okay, so packet goes in, gets broadcast out port 1, 3, 4, and 5, and the native one, or the trunk. When it goes up here into the router looks at it, looks at its routing table, and if you configured everything correctly, it will know that it doesn't need to send it out any other port except back in. And it knows that by looking at the IP addresses. So it looks at the packet that you're sending to this client here on VLAN 2, and it looks at the IP address of the client, which we'll say is .10.2.5.3, and he looks at his routing table. It goes, oh, that's part of VLAN 2 on the same port that just came in. So what the router will do, the router will remove the tag on VLAN 1. It will kibosh that tag. It will then re-tag it. Oop, I don't want to do that. It will re-tag that packet with a VLAN 2 packet, tag, and that packet will come back into the switch. The switch, if he doesn't know where that client is, will broadcast it out every port except for the one that it came in on. So that'll go up ports 6, 7, 8, 9, and 10. Okay, which clearly this client will receive it. As it goes out the port, though, that tag gets removed. So coming out of the switch will be our normal packet. It will make it to our client. The client will receive it, and then, oh, okay, this is from Buddy, and then he'll send a reply back, and that reply will go back, and then as it goes into the interface, it gets retagged. Okay, and the switch now knows that it needs to go to the router. It'll send it out to the router. The router will then remove the tag, retag it to VLAN 1. It'll come in, and the switch now knows that it belongs to that guy over there. And then as it leaves the interface, goes in the computer, it's that VLAN 1 tag is removed, and it goes to the computer. And this happens back and forth and back and forth. So that's how they talk between each other. For each VLAN, it has its own MAC address table. Yada yada yada. Now you can configure VLANs statically or dynamically. Generally, they're done statically for security reasons and stuff like that. But you can do dynamic. Dynamic is a lot more work up front. There's a couple different ways you can go about doing it. You can assign your VLANs and apply like an IP pool to it. So when a device connects into the switch with a certain IP address, it will be automatically associated to a certain VLAN. You can do it with MAC address. You can do it a couple different ways. It's a lot of legwork to get it up and going, but once it is up and going, it's like when clients move themselves around, then you don't have to make any changes. So if I'm on the 3rd floor and with my laptop and I'm on VLAN 2 and I go down to the 1st floor, plug my laptop in, I will still be on VLAN 2. The routers will automatically, especially the switches, will automatically like be able to go through the table, see, oh yeah, this client's part of VLAN 2, and I'll be on VLAN 2. And it doesn't matter where I go, when I plug in, I should be good to go. With static, not so much. Generally, static is done through ports, which we'll be doing in the lab, and it gives you a lot more control. Like, you know, when that client disconnects at a port 3, he's no longer going to be able to talk, because when he goes into like another floor, plugs into another port, it's not going to work, because his IP addresses and everything like that isn't going to work, because he won't be in the correct LAN. So have a read through all this. One thing I want to talk about is the native VLAN. The native VLAN, there's no, I mentioned there's no tagging that occurs in the native VLAN. It just, whatever's in there moves around freely. There's no tagging or untagging. This is generally where you're where you'll be managing, like the IP address for your switch will be in there for like remote management, stuff like that. Yeah. Just get into trunks. Again, trunks, you can have multiple VLANs, data traveled between there, which you have to have. You have to have trunks set up between your switches, or you just won't have connectivity from one switch to another. There's 2 standards that are used commonly with fast Ethernet environments. One is the IEEE 802.1q, which is the industry standard, and then the other one is ISL Inter-Switch Link, Cisco proprietary. That one is not that common, and it's slowly it's pretty much dead as far as I know. For the when you go on to do the lab, there's one part of the lab where it asks you to specify the encapsulation to 802.1q, and you can't because there is only one option, the 1.q or .1q. There is only one standard for it. You cannot. There's no other option. You can't put in the ISL, which I thought was funny, because it's a Cisco proprietary one. That one's pretty much died. So you don't put that. You actually can't put that line in. It won't allow you to for the routers that we have, just because there is only one standard that our routers that are using right now have. Older routers will have the ISL, but the newer ones won't. HP as well. Like I remember when I was programming an HP switch to do some VLANs, I couldn't configure the encapsulation just because it only did .1q. Okay, let's go take a look at the lab, which is lab T. I think I have it up. No, I don't. Okay. So configuring VLANs. I already went ahead and I configured this side over here with VLANs. Okay, and now we're going to do our other side. I just want to show you something. Once you're done, you have to reconfigure OSPF for every network that you have. And password 1, So if you look at all these O's, these are OSPF updates from the other network, and I programmed 3 new networks over there for because I created 3 VLANs. Okay, and these are the ones I had to change around my IP scheme, and we're going to do this at the end. We have to change OSPF because you now have you're now going to be broadcasting 5 networks. We're going to be programming 3 on FA01 plus our loopback plus the network that we're attached on our FA00. There's 5 networks that we have to be able to broadcast out. Okay, if you're not broadcasting the network, obviously nobody else will be able to talk, and you'll just be stuck within your land. Yeah, because you won't get past your router. Okay, I'm just going to work through the lab with you guys. So I need to get into my switch first. There's a few things that came up while I was going through the lab. The lab is older, so just, yeah, don't get frustrated. It's older, hasn't been updated. Yeah. Okay, we're going to switch. If you do show flash, which is the first thing it does, this should work. Okay, there is no VLAN.dat file. If there was, that means you've configured VLANs. Okay, VLAN 1 is a default VLAN that's into the router. You can't delete it, and by default, all ports fall under VLAN 1. So if you haven't assigned a port out like to another VLAN, then it's part of VLAN 1. Okay, that's just really all default to. If there was there was a file there, VLAN.dat means you've configured VLANs. We will revisit this file, like this command at the end. You'll see it. Whenever you're wiping your switch configuration, if you still have your VLAN.dat file in there, it's your VLANs will just stay configured. Okay, so you have to on top of erasing the startup configuration, you need to delete your VLAN.dat file. Okay, with the older versions of the iOS, this one is backwards compatible. Using the command VLAN database and then going into this, VLAN database brings you into a sub menu thing that you can configure your add your VLANs. You don't actually need to do that. If you just, as soon as you're in global configuration mode and you punch in interface VLAN whatever you want, it automatically creates the VLAN at that point. But I'll show you both just so you can see. So VLAN database. Okay, so I'm in the VLAN database, and you'll see that it changes to VLAN right there. So we're in there, and if you do the question mark, that's your options. So we're going to be doing 3 VLANs, 10, 20, and 666. I have those configured on the other end. So VLAN 10. Name, I'll just say voice, but it doesn't actually matter. Okay, and then I'm going to exit and show flash. Okay, there's our VLAN.dat file there, right there. When you do show run, you'll see the VLAN that you created. Oh, I lied. It's not there. We're not seeing it. No, it's not there. It's created though. It's just not. It's just not visible yet because there's nothing assigned to it. Once I actually go in and start assigning ports and everything, it'll come up and then you'll see it. Hold on. Let me see something here. If I remember correctly, the command show VLAN. Yeah, there we go. Okay, there it is. Right there. Okay, there's nothing assigned to it right now. It is created. And as you can see, all the ports right now are assigned to VLAN 1. So that command again was show VLAN. And you'll see the VLANs that you have configured. So VLAN 1, we're not going to be using that anymore. So big T. Big T. Interface. VLAN 1. Now you don't have to put in no IP address and then the full IP address and the subnet mask in this situation, just because there is only one thing. Like you can only have one IP address. You can't assign. Well, you can assign multiple IP addresses to a port, but you have to do that a very different way. But generally, when you put in the command IP address, whatever, there's only one outcome. So if you just put no IP address, it will get rid of the IP address. Okay. Okay, this isn't particularly important. If you want to do it, do it. It mentions the range command. Okay, the way the range command works is you go interface FA, and then the ones in the lab, the port assignments are the ones that were at like JSR. Those are the port assignments JSR. Here, if you do a show run, you'll see that all the FA ports are 0 / whatever. Example right here. Just pay attention to which ports you're looking for. So for the range command, do interface. I think it's range first. Interface, yeah. Interface range FA 0 / 1 to, and then how far you want to go. So an example will say 10. So fast internet port 1 to 10. Oh, messed up somewhere. Oh, they want a dash. 10. There we go. So interface range FA 0 / 1 to 10, and that will allow you to configure all 10 ports at once. So exit. I don't really want to do that right now. I don't really care about changing the duplex or the speed. Okay. And you don't need the no shutdown command because they are all active out of the gates. Okay. All right. I don't have to go into the VLAN database to create the VLANs. Not really. But the way the lab's set up, they expect you to do that first and then start assigning ports to it. I'm going to show you the other way to create VLANs, which will jump ahead. Like we'll assign the ports in a second. The other way is video interface VLAN 20 description. This is VLAN 20. Okay, and then do actually exit do show VLAN. Oh, I didn't make it yet. Because I didn't assign ports or anything to it. It does work. Trust me. I just did it. Let's check our other switch. I only did it on the other switch. There we go. That's the difference. Whenever like you don't go in the VLAN.database, that's a couple of zeros, whatever, but it's there. It works. Where was I? I am in the switch over here. Okay. I think it's not going to come up until I put an IP address to it. Hold on. So I already did up IP schemes. So for the native VLAN and like the admin side of the house, it's going to be 10.0.0.0/16. VLAN 10 will be 20.1.0.0/16, and then VLAN 20.2.0.0. Yeah, so on. For 20, it's going to be IP address 10.2.0.0, 255.255.0.0. So I had the subnets. I took that 10.0.0.0/8 network and I subnetted it into a couple different networks. This is where you're actually given the IP address for it. So .1 is going to be the router. .2 will be the switch. Okay. It's not coming up yet. I think it's not going to come up till I assign a port to it. If it exists, hold on. Show run. Do show run. Alright, there's our VLAN 20 right there. Okay, it's not going to come up in the database until I start assigning interfaces to it, going through this method and just avoiding the VLAN.dat method, or the VLAN database method, I should say. Okay. .1 0.2 0.0. Okay, there's one more VLAN we need to make. This is going to be our native VLAN. So we're going to be moving. So VLAN 1 is native by default. We're going to be moving that as the native VLAN to VLAN 666. So you just have to be able to identify that later on. So we got that. Let's start assigning ports to all of it. So this will walk you through assigning ports to it. Again, this is the manual way. It's not too bad. Let's see. Interface. Range. FA 0/1. Just back up for a second. Let's make sure that was our first one. Just 1 to 10. Range command. Okay, so now we have ports assigned to it. Okay, VLAN 1 just went down, as you saw, just because all the fast Ethernet ports that were in VLAN 1 were just moved out. So all our ports are now assigned, all our fast Ethernet ports are assigned to either VLAN 10, 20, or 666. So that's done. Now we need to set up our trunk. Okay, this is so that you can talk to the router and to other switches. The trunk, again, will handle the data of everything, untagged packets and tagged packets, regardless of which VLAN they came from. And traditionally, for your trunks, they should be on the last port of your switch. But obviously, it's up to you. So this next line here is switch port trunk encapsulation .1Q. You actually can't input the command due to the fact that that is just the only standard available. So just skip that line. That is one word. Okay, as you can see, things are starting to come up. Don't need to set the speed or duplex, it's fine. Everything auto is fine. Okay, here it gets into breaking down the IP ranges for your VLANs. Now, normally what happens is you'll get a certain amount of, well, depending, like if you're managing it, you'll just give yourself an IP pool that you'll be divvied up. If it's D&D managing it, they will say that you, for this VLAN, you will use this range and that range for this VLAN, whatever. They don't really leave anything ambiguous for you to be creative with. So what I did earlier, I went and didn't create those. So we look at our VLAN.dat file now. Or yeah, do show VLANs. is our voice that we created earlier with ports 1 to 10 assigned to it. VLAN 20 and 666. And back it up. Okay, now that our switch is all set up, this is all you had to do for the switch itself. We have 3 networks on the switch, that one for each VLAN that we're going to be using. Now we have to configure all that onto the router. Let's get into our router right now. Right now, these 2 clients, they need to change. They're on. They're plugged into VLAN 10, so they need IP addresses to correspond with VLAN 10. So for VLAN 10, it's 10.1 with default gateway 10.1.0.1. That's going to be the router. And that's a problem. 255. I have to go back and change the other one. Okay, laptops are now adapted to the new changes in the network. This guy is plugged on to I think he's plugged on the port 23. Okay, we'll worry about it in a second. Okay, so actually, yeah, I'll put him on. I'll move him to a different port. I'm not sure if I can just. Okay. Let's move him to VLAN 2. So he automatically moves to VLAN 2 just by plugging into a port on the switch that belongs to VLAN 2. Just need to change his IP configuration to match that. So VLAN 2, it's going to be 20, I mean. 2. 255. And 2. Should be good. Okay, we have our server on VLAN 20 and our laptops on VLAN 10. And our trunk from here to here is going to be on VLAN 666. Okay, so done on the switch. Let's get into the router. There is something missing on the lab. For right here, encapsulation right here, when you do the .1Q10, or well, 10 is the VLAN itself that we're talking about. when you do 666, which is the native VLAN, you have to also put a space and then native. Okay, if you don't put this in, you're gonna have issues. The router needs to know that that is the switch's native VLAN. Okay, very important, or it won't work. Your trunk won't work. Now I didn't, like, I need to go on to the lab that's on the Microsoft workspace, whatever the hell it is, Teams, Microsoft Teams, and delete the one that's on there and put this one up with this comment in there, okay, because it's not in there right now. So you may have already ran into this issue if you've done this. Okay, not worried about that. Okay, so with routers, you can create virtual sub interfaces. They're called sub interfaces, and you can essentially, rather than using like, so we have 3 LANs. Rather than having 3 ports on the router, physical ports on the router, we can just use 1 physical port on the router, but 3 logical interfaces. And that's where sub interfacing comes in. Okay, so you need a sub interface for every VLAN. Okay, and that's what we're going to be doing. We're going to be taking 1 physical port and creating like 3 logical ports. So first thing you have to do is just set up our internal port for this. So interface FA0/1, no IP address. Okay, you don't have to put the no shutdown; it's still up. Okay, and okay. So then now we're this is where we're going to create the sub interfaces. Interface FA0/1. So that's the port we're talking about, the physical port, FA01. And then we put the dot. You put the dot, and then you put in essentially the VLAN number. Okay. So the first VLAN number we have is 10. Okay. Description. VLAN 10. .1Q, and then you have to put in the VLAN number, and the .1Q and then the VLAN number. That's how it knows what to expect and what to do. I.e., when a VLAN 10 packet comes in that's tagged with the 10 on it, it knows to remove it. It can identify and remove that tag. So it's very important that you have it in there. 10. Now think of it as 3 physical ports, and so you're configuring 3 like gateways, 1 for each network. Okay. 10.1.0.0 255.255.0.0. So just a reminder, we stole 8 more bits for the network address. Oh, and I used the network address, not the router address. The router is going to be .1. Okay, now I have to do this for the other 2. Okay, right here is where you have to put the native. It's not in the lab, just because you do this 3 times and the last one's unique. I'm assuming that's why it's there. So right here is we put native. If you weren't sure, we do the question mark. It says native right there. Okay. IP address. Okay. So all the VLANs are now configured. The router can communicate between the two, and we can view that easily by going onto this router here. Web browser. This better work. 10.2.0.250. There we go. So there we go. We got he can talk. He's on VLAN. He's physically on VLAN 10, plugged into port 2, and this guy is on VLAN 20. So we have communication going back and forth due to the fact of the router. So every packet this guy sends goes to the switch, goes to the router, gets re-tagged back to the switch, back to the server, and it does this all day long. Okay, like that. Now these guys won't be able to talk to these guys due to the fact we are not doing something important right now, and that's advertising our new lands. Okay. Uh, 10.2.0.250. Damn it, it's working. It is working due to the fact that he is broadcasting all of 10.0.0/8. He's broadcasting, he's advertising all that. So whenever he receives a packet to go to the 10.0 the 10.0.00 network, it sends it here because he knows where it is. But if we went with a different IP scheme in here, it wouldn't work. But we do need to broadcast our networks that we do have. That's very important. So we have to go into our router, and then if we do a show run, do show run. You look right here, we need to update that. This is no longer the 10.0.0.0 is no longer a /8, and it's 3 different networks. So we need to fix that. So first thing we gotta do is copy this exactly as it is. OSPF 100 is what we got going on. Put a no in front of it. Paste. Okay. And now we put in our networks. Network 10.0.0.0 and 0.0.255.255. Area 0. Network 10.1.0.0 0.0.255.255. Area 0. Network 10.2.0.0 0.255.255. Area 0. do show run. There we go. We now have 5 entries into our networks. Okay, because we have 3 networks that we're running. Okay, and those that convergence should have happened. It's a very small network. That convergence should have happened already, and this guy should be tracking those now. So if you go in here, show IP route, we should be able to see all the other networks now that are in the 10.0 world. 10.0, 10.1, 10.2. So we have 3 networks, and everything is hunky-dory now. Okay, and that's VLANs in a nutshell. We now have these guys, their data isolated to their land, and this guy, his data isolated to his land. Yeah. If you have any questions, just let me know. Text me or ask the question in Microsoft Teams. Yeah, I'll update the lab that's on the Microsoft Teams right now. All right. Have a good one. VLANs.